Probability. So I used to go to college by bus. So here is the bus stop, and here, let's say, suppose it's my home. So I used to go to college by bus, and bus usually arrives between 8 o'clock to 8:10, and it stays for 10 minutes. So basically, bus would be there from 8 to 8:10, but sometimes it might come 2-3 minutes early or 2-3 minutes late. So I realized that if I am there at 8:05, if I am there at 8:05, then there is high chance of me not missing the bus. Right? So what are the chances of some event happening or not happening is nothing but probability. So probability helps us to make better choices. So probability is denoted by P of A, where A is the event. So P of A means the probability of occurrence of A, and it is given by P of A, where P of A will be equal to number of favorable outcomes, divided by total number of outcomes. Okay, basically it's divided by. So probability is nothing but number of favorable outcomes by total number of outcomes. For example, let's say there are 4 green balls. Let's say there are 4 green balls and there are 2 black balls. Now I am asking, now you have to randomly pick one of the ball. So let's say these both are in a box and you have to randomly pick one ball. Now I ask, what are the chances of getting a green ball? Or I may ask, what is the probability of getting a green ball? What is the probability of getting a green ball? So when we just recall our definition, it's P of A is number of favorable outcomes by total number of outcomes, where A is the event. So you have to find the probability of getting green ball. Since our event is getting green ball, so we have to find the probability of getting green ball, which is number of favorable outcomes. Number of favorable outcomes means, what is our favorable outcome here? Favorable outcome is number of ways we can get a green ball, which is 4, by total number of outcomes is 6. So favorable outcomes are 4 green balls, right? If we choose one among these balls, we have more chances of taking the green ball itself. That means we have the number of favorable outcomes are 4 and the total number of outcomes are 6. So 4 by 6 is our probability. So in the previous video, we have talked about certain events and impossible events. So certain events are something where we can say that will definitely happen. So for the certain events, probability will be 1. And for impossible events, probability will be 0. So the probability value lies between 0 and 1. If you see in options any value where it is lesser than 0 and greater than 1, you can say that would definitely not be the answer, because probability always lies between 0 and 1. And now let's see another example. Now we are tossing a coin. We are tossing a coin, and I am asking what is the probability of getting a head. So now what are the two chances that you have? We have we might get a head, we might get a tail. These are the two different chances we have. We might get a head or we might get a tail. So the total number of outcomes are 2. Total number of outcomes are 2. In this, what is the probability that I'll get a head? Probability that I'll get a head is 1. One of the outcome favors head by total number of outcomes are 2. So probability of getting a head is 1 by 2. Similarly, what is the probability of getting a tail? It is also 1 by 2. 1 because there is only one outcome which favors getting a tail, and total number of outcomes are 2. So probability of getting a tail is 1 by 2. So here when we observe, the chance of getting a head and chance of getting a tail are same. So when we get these kind of scenarios where the chance of getting a head and chance of getting a tail are equal, these are equally likely events. These are equally likely events. So in equally likely events, the chance of getting one event is equal to the chance of getting another event. That means the probability of one event will be equal to other event. Complementary events. It is denoted either in this way or in this way. So we have seen that P of A is probability of an event happening. So P of A complement is opposite to it. It is the probability of that event not happening. It is the probability of the event not happening. So now for example, two coins are tossed. Let's say two coins are tossed. What are the total possible outcomes? So in one coin we might get tail, other coin also tail. One coin we might get tail, other coin we might get head. One coin we might get head, other coin tail. Heads, heads. These are all the possible outcomes. Now, if I ask, what is the event of getting at least one tail? So A is event of at least one tail. So P of A is the probability of getting at least one tail. Then A complement is event of not occurring at least one head. Okay, event of not occurring at least one tail. If P of A is the event of getting at least one tail, then A complement is opposite to it, which is event of not getting any one tail. So how do we do it? So P of A plus P of A complement will always be 1. So P of A complement is nothing but 1 minus P of A. So now what are the events of getting a tail? So what are the favorable outcomes of getting a tail? We can say they are tail is one of the favorable outcome, tail head, head tail. In all these three scenarios, we are getting at least one tail. And total outcomes are 4, as we have seen. Total outcomes are 4. So what is P of A? P of A is 3 by 4. So getting at least one tail is 3 by 4. Now probability of not getting at least one tail is nothing but 1 minus 3 by 4, which is 1 by 4. Right, so what are the possible or favorable outcomes for not getting at least one tail is only heads and heads, right? In this case also we see it is 1 by 4 because 1 is the favorable and 4 are the total number of outcomes. So this is about complementary of an event. Let us take another example. So there is a scenario where we say only 1 in 10 wins a lottery. 1 in 10 wins a lottery. Then what is the probability of not winning a lottery? What is the probability of not winning a lottery? So what is P of A? A is the event of winning a lottery. Then A complement is the event of not winning a lottery. So we can consider A as event of winning a lottery. And P of A complement or A complement is the event of not winning a lottery. So what is P of A? It is clearly told that 1 in 10 wins a lottery. So it's 1 by 10. So P of A complement would be 1 minus 1 by 10, which is 9 by 10. Now let us talk about odds in favor of an event, odds against an event. So first let's see what is odds in favor. So odds in favor of an event is nothing but the ratio of P of A and P of A complement. So we can also tell it as the ratio of successful is to unsuccessful. Whereas odds against is P of A complement is to P of A. It is ratio of unsuccessful is to successful. Now let us solve some questions on probability. Now in this question we are asked to find the probability of throwing a total score 8 with 2 uniform dice. So we are going to take 2 dice. So when we throw these 2 dice, what is the probability of getting score 8? So we have to know what are the possibilities of getting a score 8 and what are the total number of possibilities. So for getting score 8, the possibilities are I can get 2 in this die and 6 in this die. 2 plus 6 is 8. I can similarly get 6 and 2. 6 number on this die and 2 on this die. And what are the other possibilities? 3, 5, 5, 3. And another possibility is getting a 4 on this die and 4 on this die. So these are the possibilities of getting sum 8. Now what are the total number of possibilities? Now if we consider 2 dice, here we can get 6 numbers from 1 to 6. Here also we can get 6 numbers from 1 to 6. So the total number of possibilities will be 36. Okay, we can maybe list down if we directly did not understand how it is 36. It's just a combination 1 with 1, that means 1 on this die, and we can get another 1 on this die. Similarly, 1 on this die, 2 on this die, 1 on this die, 3 on this die, 1 on this die, 4 on this die, 1 on this die, 5 on this die, 1 on this die, 6 on this die. We got 6 possibilities. That repeats with 2. 2 on this die and 1 on other die. 2 on this die and 2 on other die. So on. So we have 6 plus 6 plus 6 plus 6 plus 6 plus 6. So for 1, 2, 3, 4, 5, 6 on the first die. So we have these combinations. So in other words, if we want to understand, we can also understand it in different ways by just writing the possibilities. But I hope this must be clear. So we got the number of possible outcomes for getting a total score 8 are 5. 1, 2, 3, 4, 5. And the total probability, it's not just total probability, it's total number of outcomes are 36. So the probability of this event getting total score 8 is, so first number of favorable outcomes which are 5 by total number of outcomes which are 36. So the probability of getting total score 8 is 5 by 36. Now let us solve another question. Question says, a page is opened at random from a book containing 600 pages. What is the probability that a number on the page is perfect square? So we have a book. Book contains 600 pages. Now randomly we opened a page. What is the probability that the page we opened is a perfect square? So for this, we have to list down what are the favorable outcomes. That means what are the pages where we have, or what are the page numbers where we have a perfect square. For example, if I randomly opened page 1, it is a perfect square because 1 square is 1. If I randomly open page 36, it is also a perfect square because 6 square is 36. So we know that the total number of pages are 600. So how many perfect squares are possible? Can you just think? So it starts from 1. 1 square is 1. Then if I consider 2, 2 square is 4. If I consider 3, 3 square is 9. Similarly, we know that 25 square is 625, but pages are only 600. So then we have to take 24. If we take 24, 24 square is 576. So I can also open 576th page. It will also be a perfect square. So there are 24 perfect squares from numbers 1 to 600. From 1 to 600, we have 24 perfect squares. So these 24 are the favorable outcomes out of all these 600 pages. So the probability of getting a number on the page which is a perfect square is 24 by 600. Let's move on to next question. If 2 cards are drawn from 52 pack of cards at random, find the probability of getting both club cards. So usually in deck of cards, So deck of cards is very commonly asked question in probability. I mean, with deck of cards, we have lot of questions that are framed. Now, if we see here, I don't have red color in my what colors for the pen, so I had to do it with this pinkish color. So, but we have red and black as the colors in our deck of cards. So there are totally 52 cards. So now 52 cards are divided into 26 red colors, this one and 26 black colors. This is black and this is black. And we have 13 cards from each category. So in red, heart, we have 13 cards. In red, diamond, we have 13 cards. In black, club, we have 13 cards. And black, spades, we have 13 cards. So we have 13 cards in each category. So these 13 cards, what are these 13 cards? These 13 cards are A, sorry, we don't have one. It's A, then 2, 3, 4, 5, 6, 7, 8, 9, K, Q, J. So these are the cards. So these 13 cards are in hearts in red color. These 13 cards are diamonds in red color again, club and spades in black color. These are the divisions of deck of cards. I should have drawn a flow chart, which I usually do, but I hope this is also understandable. Now, coming back to the question, it's if two cards are drawn from a 52 pack of cards, find the probability of getting both club cards. So, if we know permutations and combinations, we would easily understand how do we pick up two cards. Okay, we are just selecting two cards from this entire deck of cards. We are selecting two cards. Even though you don't understand permutations and combinations now, I can tell you in an easy way. Now we are selecting two cards from this entire cards. Imagine you just have a box of cards and you are just selecting two cards and picking them up. You are just taking these two cards from all these cards and you are picking these cards up. So when you are doing those in these 52 cards, we denote it as 52C2. Okay, we are selecting two cards from this 52 cards. So this is what total number of outcomes. Now, what are favorable outcomes? They are asking getting both club cards. So getting both club cards is our favorable outcome. So how many club cards are there? 13 club cards. So from 13 we are taking 2. So from 13 we are selecting 2. These are the favorable outcomes. So now our probability is equal to 13C2 favorable by total number of outcomes 52C2. So we can solve it like this. 13 here it's 2, so we just write two numbers, 13, 12, and here it's 2. So 52 into 51. If it was 3, we write one more number, which is 50. So we should do in this way and we get 1 by 17. I hope this question is clear. Let's move on to the next question. Find the probability that a leap year will have 53 Sundays. So these leap year questions, usually most of the people will find it little difficult. I'll try to gather as many questions as I can from the topic of leap year and probability. So yeah, coming back to this question, they're asking the probability that leap year has 53 Sundays. So first let's understand what is leap year. Of course, we all know what is leap year, but yeah, leap year contains how many days? 366 days. One day extra than other years, right? A leap year contains 366 days. Okay. Now, nearest 7 multiple we have to see. Okay. What I meant is 366 a multiple of 7? No. Why I am asking if something is a multiple of 7 is, if I say there are 7 days, I can say that 1 week. It's 1 week. If I say 14 days, I can say that it's 2 weeks. Similarly, I want to know how many weeks are there in 366 days. Okay, if we go by that, 366 is not a multiple of 7. Okay, if I see 365, it is also not a multiple of 7. Let's see 364. Is it a multiple of 7? Yes or no? Yes, it is a multiple of 7. When you divide by 7, we get 52. So 364 is a multiple of 7. Now, why do I need a multiple of 7? So now I can say that, so 52 weeks are there and 2 extra days are there in this 366 days. Okay, so that means these 364 is nothing but they are 7 weeks. 364 is nothing but 7 into 52, with which I can say that 364 is nothing but 52 weeks. 52 weeks. So, and we have 2 days extra, right? We have 2 days extra. So, this leap year contains 52 weeks plus 2 days extra. I can't say extra though, plus 2 days additionally. Now, these 52 weeks, that means these 52 weeks has 52 Sundays, Mondays, Tuesdays. So 52 weeks have 52 Sundays. In these 2 days additionally these 2 days can be Sunday, Monday, or Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday, Sunday. So these 2 days can be any of this combination. So but we want to see what is the probability that it will have 53 Sundays. So this is our favorable outcome because the 2 days can be Sunday, Monday, or this could be our favorable outcome. So 2 is our favorable outcome out of 1, 2, 3, 4, 5, 6, 7 possibilities. So our probability is 2 by 7. I hope this is clear. Also, if you have got doubt why I have taken this and this as the favorable outcome, it is because we are asked for 53 Sundays. That means one Sunday more than what we have in 52 weeks. So that Sunday we get in this combination in Sunday, Monday, or if these 2 days are Saturday, Sunday, we still have that Sunday as our possibility, so that we will fulfill our criteria of 53 Sundays. So I assume it was clear, but just in case, I am just repeating why these are favorable outcomes. Next question. If 10 coins are tossed, find the odds against the event of getting at least 2 heads. Now first, let us see the total number of outcomes. When one coin is tossed, we might get a tail or a head. When 2 coins are tossed, we might get tails, 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 heads, heads tails, heads heads. When 3 coins are tossed, these are the possibilities. So when one coin is tossed, we have 2 power 1 which is equal to 2 possibilities. When 2 coins are tossed, we have 4 possibilities. Similarly, when 3 coins are tossed, we have 2 cube which is equal to 8 possibilities. So in the question we have 10 coins tossed. 10 coins are tossed. So the total possibilities are 2 power 10. Now next part of the question is event of getting at least 2 heads. So next question, next part we have is event of getting at least 2 heads. Now first, in order to understand it better, let us see for 3 coins. Now here we have at least 2 heads, 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 whereas here we don't have at least 2 heads. Here it's just one head, one head, one head and no head. Okay, so by complementary I will find out this. Okay, normally if you say what is the probability of getting at least 2 heads, we will say that 4 are the favorable outcomes, 8 are the total outcomes, so it is 1 by 2. Let us do in a complementary way, okay, which is probability of getting at least 2 heads is 1 minus probability of getting a 0 head plus probability of getting 1 head. Okay, because getting 2 heads means 2 or more. So opposite to it is getting less than 2, which is 1 or 0. So 1 minus 0 head, what is the possibility? Only 1. Okay, so it will be 1 by 8 plus 1 head, it's 3 by 8. So which will be equal to 1 minus 4 by 8, which is again 4 by 8, which is 1 by 2. So by complementary also we got the same answer. So we will be solving this question by using the complementary only, because it is not possible to count all the cases of having at least 2 heads when 10 coins are tossed, because we have multiple cases, all heads, or 2 heads, 3 heads, 4 heads, 5 heads, 6, 7, 8. There are so many possibilities which is not possible for us to calculate. So we use complementary only. So probability of getting at least 2 will be 1 minus probability of getting 0 plus 1 head. Now for this question of 10 coins tossed, probability of getting at least 2 heads will be equal to 1 minus, for 0 heads when 10 coins are tossed, it is 10C0 by 2 power 10, plus for getting 1 head it is 10C1 by 2 power 10. So why 10C0 as a favorable outcome? Because there is just one possibility where you have 0 heads, which is all tails. 10C0 is 1. So this is just one of the case. Now why we have 10C1? Can anyone take a guess? So 10C1, because we are just choosing one position out of the 10 positions which we can give to the heads. So out of the 10 positions, we are choosing one position which we can give to the heads, but that happens 10 times, right? Because we don't worry or bother about the other order of remaining positions. Okay, either I can place heads here, here, or in this place, or in this place, so on. Okay, because we have to get only once. So order doesn't matter for the remaining tails. Now I recall an example that imagine you have 10 empty chairs. When we go for a function, there are 10 empty chairs in a row and we need to pick one chair to sit. Now how many choices we have? So out of the 10 we choose 1. 10C1. Okay. So we don't care about the order of the empty chairs, we just pick one. Okay, so this is just choosing one position for a head when 10 times the coin is tossed. So coming back to the problem, so this is the probability of getting at least 2 heads. So now this is probability of getting 0 head or 1 head. So maybe I'll directly calculate. 1 minus 10C0 is 1 plus 10C1 is 10 by 2 power 10, which is equal to 1 minus 11 by 2 power 10, which is equal to 2 power 10 minus 11 by 2 power 10, which is equal to 1024 minus 11 by 2 power 10, which is equal to 1013 by 2 power 10. Now this is our P of E, probability of this event occurring, right? Now we want probability of event not happening. Okay, E complement, that means probability of not getting at least 2 heads, that which is equal to probability of getting 1 head or 0 head. I should have calculated this before so that our calculation would have been even more easier, but I think it's okay. So it is 10C0 by 2 power 10 plus 10C1 by 2 power 10, which is equal to 11 by 2 power 10 as we have calculated earlier. Now odds against an event, our question is to find the odds against this event. So odds against this event is nothing but P of E complement is to P of E. So which is equal to 11 by 2 power 10 is to 1013 by 2 power 10. So 2 power 10 gets cancelled and our answer is 11 is to 1013. Now moving to the next question. 5 coins are tossed. What is the probability of getting sum 12? So here we have few things to concentrate. One is when 5 coins are tossed, what are the total possibilities? As we have seen in the previous question, it is 2 power 5, which is equal to 32. Okay, and I think I missed some part of the question, sorry for that. So the question is 5 coins are tossed and they are marked as 2 and 3. Faces marked as 2 and 3. Instead of heads and tails, we have numbers 2 and 3 on it. So we are asked what will be the sum, or what is the probability of getting sum 12. So what is a favorable case to get sum 12? If, let's see, if all are 2's, what do we get? So it's just 5, no? So if all are 2's, we get 10. Okay, if all are 3's, we get 15. We want sum 12. So this is not the case. So the favorable case is 2, 2, 2, 3, 3. Okay, 6, 7, 8, 9, 10, 11, 12. So this is a favorable case. And the other favorable cases are by just changing the positions, no? 2, 3, 3 and so on. So we will directly use the rearranging way, we will directly use the permutations. So how do we arrange these in different ways? So there are 5 items, 5 factorial by, since these are repeating, 2 is repeated 3 times, so 3 factorial. How many times it is repeated, that much of factorial we have to put. Now 3 is repeated 2 times, so it is 2 factorial. So it's not, we are not writing these numbers here, it's how many times these numbers are repeated. So 2 is repeated 3 times, so it is 3 factorial, and 3 is repeated 2 times, so it is 2 factorial. Now why do we have to even divide it like this? Is to avoid a case where we are permuting these two only. Now, okay, if I don't divide, it means that this two I am bringing here and this two I am bringing here, and we are counting this again. Okay, these repeated kind of things we have to avoid. So we divide the number of times they get repeated. Okay, so this is the favorable. This is favorable. So the probability of getting sum 12 is equal to 5 factorial by 3 factorial into 2 factorial by 2 power 5. So when we solve this, this is 5 into 4 into 3 factorial by 3 factorial into 2 factorial, 3 factorial, 3 factorial gets cancelled, 2 2's, and here you have 32. This 2 and 32 gets cancelled. So the answer is 5 by 60. Let's move on to the next question. 2 fair dice are rolled. Find the probability that the difference between the numbers is at least 2. So what they meant to say is, now this is a die, this is a die. In one die maybe I got 5, in other die I got 4. The difference between them is 1. So this is not a favorable outcome because the difference should be at least 2. Let's say I got 6 here and 4 here. The difference is 2. So this is a favorable outcome. Let's say I have 6 here and 1 here. The difference is 5. Is this a favorable outcome? Actually yes, because they are saying the difference should be at least 2. At least 2 means 2 or more than that. Okay, now so 1 and 1 will not form, 1 and 2 is also not possible because the difference is not 2, right? Because 2 minus 1 is just 1. If you take 3, it is possible. So we have to continuously take these values. So instead we will go for complementary approach. Okay, that means we will consider the event, we'll consider the complementary event, which is difference is 0 or 1. So at least 2, no? So we'll consider the difference as 0 or 1, and then we will subtract. We will take probability of the event is 1 minus probability of its complement. So now what are the possibilities where the difference is 0 or 1? 1 comma 1, 2 comma 2, 3 comma 3. Here the difference is just 0. Here the difference is 0. Now what are the cases where the difference is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Okay, then again 2, 1. Then we have 3, 2, 4, 3, 5, 4, 6, 5. Okay, apart from this everything else has difference at least 2. So what are the favorable outcomes here? 6 and here are 10. So total are 16. So A complement is probability of its complement is 16 are the favorable outcomes. By total outcomes when two dice are rolled is 36, which is equal to, okay, let's keep it as it is. And now the probability of event is 1 minus 16 by 36, which is equal to 36 minus 16 by 36, which will be equal to 20 by 36, which is equal to 5 by 9. If you want, we can cancel it here itself, but I think it's okay to not do it. we can do it 1 minus 4 by 9 and get 5 by 9 as well. Next question. Two numbers are selected from 1 to 100 without replacement. Find the probability that minimum of two numbers is less than 70. Now, when two numbers are selected from these 100 numbers, from 100 numbers, two are taken out. Okay, this will be our total possibilities. Now, what is the probability that minimum of two numbers is less than 70? Okay, so minimum of those two numbers should be less than 70. That means those two numbers when you pick up, they should not be from 70 to 100. Okay, because if you pick up both the numbers from this range, the minimum also will be from this range. Okay, so this is the complementary event. We should not be picking from here. Okay, so the E complement will be 70 to 100. There are 31 numbers. 31 by 100 C2. Okay, so what will be the probability of this event? 1 minus 31 C2. It is picking two numbers from this 31 C2 by 100 C2. Next question. 3 fair dice are rolled. Find the probability that the greatest number on the die must exceed 3. Now, when 3 dice are rolled, what are the total outcomes or total possibilities? Which is 6 into 6 into 6, 216. Now, what is a complementary event again? Because probability that greatest on the number must exceed 3 means it should be 4 or 5 or 6. Okay. If I take complementary, it means that 1, 2, 3. If these three numbers are on the dice, okay, if all these three numbers are only on the dice, then the greatest would be 3 only. Right? If any of this number comes, they will become the greatest. But if these three numbers are there, the greatest would be 3 only. So, which is complementary to what we expect. So, how do you arrange these? So, in this place, so the combinations goes like this, right? Here it can be 1, 2, 3, or it can be 1, 1, 1, or here it can be 1, here it can be 2 and 2. Similarly now, so this place has 3 chances. It can get a 1 or a 2 or a 3. Here also you can get a 1 or a 2 or a 3. Here also you can get a 1 or a 2 or a 3, and you can form combinations with all of them. So 3 chances into 3 chances into 3 chances. Okay, similarly with 2 you will have those chances. Similarly with 3. So the favorable outcomes for the complementary event are 3 cube, which is 27. So E complement would be 27 by 216, and which is 1 by 8. And what would be the probability of the event? 1 minus 1 by 8, which is 7 by 8. If anything is not clear, please let me know in the comment section. I'll try my best to explain it with little more clarity. That's all for this video. Let's meet with few more concepts and lot more questions in the next video. Thank you so much everyone.